I don't know about you guys, but I'm getting a little bit sick and tired of dealing with these things. Maybe it's time to evolve. What is going on, everybody? Welcome back to the garage, and as always, I want to thank you for taking the time to subscribe, click that like button, and check out things like the Patreon. Great information out there, great resource for people that need one-on-one help with tuning. GoatRopeGarage.com will get you there as quick as humanly possible, and as always, you can share the link directly to our YouTube homepage at tuning101.com. So easy to remember, so great. That all being said, if you are a patron, you probably already know this, or if you've seen me post on some of the Friends of the Channel's websites, our YouTube page, Low Buck or Dirt Floor, you might have seen me hinting at finally picking up a Holley unit. That is correct. We have a Terminator X Max on the way. A little background on this ordeal. I keep on finding weird picadillos about this engine. In fact, being that it is a 58X reluctor instead of a 24 like I thought initially. The reluctor pickup style is different. It should work with the E67. The cam sensors are a whole different story. They're not the traditional 4X that goes with the 58 as far as I can tell. There's just a lot of weird stuff going on. I don't doubt the fact that we can get the E67 running now that I know that there is a 58X reluctor wheel in here. And everybody's like, oh, just change the reluctor wheel out. Well, the reluctor wheel is smack dab in the middle of the crank. You can't change it out. You'd have to change the whole crank. We're not going to crack this motor open. No way, no how, no reason. So that being said, there's still going to be a couple more videos on the daily vlog where we attempt to finish out the E67 swap, see if we can get that running. But that all being said, we do have the Terminator Max on the way, which is an answer to not only this platform, but what is going to go in this car next. No matter what LS series motors that we put in here, a 24 tooth or a 58 tooth, we will be able to support it. And whenever you buy the Terminator Max, it gives you the option of buying a specific setup. I went with the LS1, LS6 setup only because of the injector connections that match up, because these are the EV6 or the used car, US car connectors. And so the rest of it, I'll have to do some harness adaptation because I know that the throttle body's not going to hook up. I know that the ignition coils are not going to hook up, but I've already bought the stuff to go ahead and build those adapter harnesses. That all being said, if you want to end up going with a 58 instead of a 24, you just have to be aware that the big difference between the two is the sensor type and the reference voltage. The 24s, a lot of that stuff ran on 12 volts, unless it's a North Star. For some reason, the 58s on the North Star may be the only 58X reluctor setup that runs on a 12 volt reference sensor. That is yet again another reason why this is all so confusing. But the later Gen 4 stuff after the LS2s go, and maybe even the LS2s, I don't know. The E40 is kind of one of those weird platforms. Go to a 5 volt reference on the 58X setups. So you can run both on any Terminator X Max. It doesn't matter which harness you get. You just have to change the wiring for the reference power signals going out. So as long as you're comfortable with digging through and making adjustments on the harness that you just bought, you can use the base one for everything. There's some cool stuff, but that all being said, this video is about taking your HP Tuners file and developing your Terminator Max tune from that, your base tune from what you already have in your vehicle. And surprisingly, it's not that hard. Let's jump into it. Okay, so I have the Terminator X software opened up here. You can download this for free out there if you want to go play with this and kind of check it out on your own. This is one that I've already started. Instead of building this directly from scratch because it takes quite a while, I'm going to walk you through the different steps that I used and showed you how I derived a lot of these values to get them into this software. Starting off, it's pretty straightforward. One of the only things that bugs me is this being the ECU setup. I wish that were over here first. The order of this is a little bit weird. You can't drag and drop it. But that all being said, let's dive right in. We're going to start with the system setup, ECU configuration being the big one. We are using the Terminator X Max. This software only works with the Terminator X or the Terminator X Max, but you'll notice this looks a lot like the EFI software or the Dominator software. A lot of this is built on the same platform, so Go into engine parameters here. I'm set up for an 8 cylinders. This all is pretty straightforward. Engine displacement 4.6 liters. Load sensing is where it gets a little bit different. This is where you can choose how you were doing it. Speed density, we're actually going to use volumetric efficiency, which is the map sensor. You can also do alpha N on this, so there's a good chance. Somebody asked me months ago, any alpha N tuning videos? I will probably do an alpha N tuning video, and that's basically doing a fueling and spark table based off of throttle position. Not the most ideal unless you're on the track only. Then this is weird. We've got a fuel type drop down, gasoline or E85. It doesn't change anything that I've been able to see. That's one of my biggest complaints about this is it only reads in AFR, no lambda option. Hopefully somebody over at Holley wakes up, gives you the option, because that wideband sensor, as you can see, we're using the Bosch 4.9 that's going to be provided with the kit. That thing's reading in lambda. The software is actually converting it to AFR. So why not give you the option to just see the lambda? Injection system, obviously it's a multi-port. You could do throttle body intake style. Fuel pump prime, I've got a couple seconds on there. This is if you're going to use the fuel pump relay to control your fuel pump. In this case, we will be, because this does not have a fuel pressure control module. And even if it did, I don't know that it would work without the factory ECU in there. We are targeting 58 PSI because that's what this system is set up to run on, as the max pressure on there. And then the injector end angle. This is something that we're going to need to grab out of the tune. The tune that I have opened up is one that I set up with the XLR-V injectors with the XLR-V tune. So if we come over into our fuel table on here and we go in here, we will actually have a minimum injector pulse. Nope, that's the wrong one. Sorry. We are looking for, let's scroll down here, injection timing boundaries. This is the latest possible position to inject, and it is 590 degrees. So we have copied 590 degrees over here in the injector end angle. Now, we're not going to do an end angle table right now because we're not that granular on controlling the injectors. Now, for the fuel injector information, there is a ton of injectors in here. Look at all these options. Obviously, the injectors we're using don't exist in here, so we're going to have to do a little customization. I know they're around 47.7 pounds per hour, and the way that I derive that is by going in and looking at our flow rate versus KPA at 0. If you have one that is versus pressure instead of manifold vacuum, look for the one that is at your set point flow rate. So at 58 PSI, I would grab that number and transpose that over into the Terminator X. Same ordeal, we are rating these at 58 PSI at 47.7 per hour, and then we're looking for minimum injector opening time. That is the one that we clicked on earlier. The minimum injector pulse is 0.648 milliseconds. We copy that value over to 0.64 milliseconds, and then the off time is the offset or the end time. We can do the same thing where we come down to the offset and we went versus volts AC. Now, if you look, there's a lot going on in here. We had to change the Terminator table over. If I scroll down here, you can see that we have voltage values on here. I grabbed the voltage values for 0 manifold vacuum, aligned them up, went in there and found 7 was at 3.2. So, you know, well, we don't have a 7. We start at 8, found 8 being at 2.1 around there. And in fact, this is actually set off at a vacuum. So I need to adjust this table, but you can see where you could come in here, grab this offset, and put it in there. There's another one on here versus map. No, that one's zeroed out. And we're not going to use injector temp, obviously. So that's how you choose between the two if you're doing it on HP tuners. But we have these values populated in there that gives us a good starting point to make sure we have decent injector data. This should get us running. And then on our injection strategy, we're running sequential, obviously. Now that's going to be a little bit different as we move down through this and look at some other stuff. Let's dive into the ignition parameters. This is what's important for this specific platform. Our ignition type, if you drop it down, there is a lot of the standard stuff, 24 tooth, 58 tooth GM. We are doing custom for a reason though, and if you go into configure, you'll see that we're running 58 tooth, but we have the option of coming in here and changing this from 4X to not used, which we'll probably start out with. Now, it'll pop up and say that it does not support sequential, and it's going to go bank to bank, which is, bank fueling is where you're basically fueling one side than the other. But if we go over to not used and come back into the engine parameters where we have bank to bank, we can now do untimed sequential, which will still do sequential injection, but it's not using the cam timing to determine which valve is open. And supposedly this works a little bit better without having the cam timing than bank to bank, especially down low on idle. So it gives us some options. On top of it though, we can come in, they make a kit where you can add your own sensor on there and then do single pulse injection, and that allows you to do sequential fuel injection. It's about 130 bucks. There's a good chance if we can't get the existing cam sensors to work on this one, we will flip over, install that kit, drill one of the cams, and add that sensor in. So for now, we're gonna leave it as a 4X and we'll see how it works on that. And then of course, our output setup, we're disc coil on plug. Yeah, that's what it is. It's a GM platform with coils. So, and then dwell time, we can go in and look at the factory dwell time. If you come into Spark, come over to dwell, base dwell time is, let's look at 12 volts, 6.5. So we can come over here and we can bump this up a little bit. 1.5 is a little bit low, so let's go 4.5 dwell time. We'll try that out to begin. If we need to add more dwell time, if we're getting misfires because we're not igniting the spark plugs hard enough, we can add some dwell time. Or you can enable the dwell table, which will allow you to basically build a, I don't think that it is a 3D table or a 2D table, I think it's a 1D table like this. But you have the options. That's the cool thing about doing a aftermarket ECM like this, is you have options. So if we go back down through some of this stuff, we're not too concerned about setting up our warnings right now. Coming back through, we can set high, low alarms, etc., and you can trigger outputs and things like that. Basic I/O, we will be controlling the fan with the fan relay, or we will be triggering the fan relay on this. We've got it kicking on 200. That's probably not the best, but we can make adjustments. Same ordeal, we can trigger the AC to shut off whenever we're at above 80% throttle, or if our coolant gets too high. And then on top of it, we can do an IAC kick, which basically bumps our idle up whenever the AC's on. And right now we've got set to 10%. Idle set point is 700, that'd bring us up to 770 RPMs whenever it's on. TCC, we're not worrying about this because we're not doing trans control through this. We're going to be using the PCS unit to do that. So any of the trans stuff on here, we're not looking at. But if you are doing the trans control with your Terminator X Max, there's where the TCC IO lockup stuff works. And then staging, this is basically a bump box. You can tie into a bump box to do all that stuff. Closed loop learn, this is the important stuff. This is where the wideband will automatically allow learning on here. And closed loop parameters, this is just like standard closed loop on our vehicle, except we're using a wideband. We're allowing what is in these different pressure ranges, 25 plus or 25 minus. That's percent of range increase. Now on the learn parameters, this is whenever we go in and actually do the initial learn. We can learn up to 100% additional fuel, or we can subtract 25% fuel on the learn side of it. We'll get into that whenever we look at the fuel injection side. Individual cylinder. You can actually go in, adjust timing and fuel injection rates on individual cylinders. So if you know you have a couple cylinders that are running hot spots because they're not getting enough fueling or they have too much timing, you can dial those back. A lot of times that's going to be 7 and 8, or the last two cylinders on a LS platform. Inputs and outputs, this ties back. This just shows you what has been defined. If you come to the pin map, you actually have to draw some of these in. So for the AC kick, we would have to add this to a input to let us know whenever AC's on, and then we've got 4 available inputs that we can map that to. Same ordeal, we've got 4 available outputs. You can see I've got one mapped already to RPM, and we'll talk about that here in a bit. Okay, so that being said, let's jump over to the fuel table, take a look at it. We've got a base fuel graph. If you look at this, it's not too ugly of a graph. Now, where did I get this base fuel graph? This is directly from our VVE table in this situation. Now, the problem is that this graph, the X and Y axes are on the bottom and side as opposed to the top, and so our low value is lower left instead of upper left. Now, what I did is go into our VVE table, and I changed our scaling to match. So specifically on our manifold absolute pressure, we can't edit how many cells are in here, but we can edit the range. I've got this set up for 1 bar, which means we're going from 10 to 105. I came in here, did the same, 10 from 105, and then what I did was copy the whole table into a spreadsheet and then sort ascending on the first row, because the lowest value is up top, highest value is on bottom. it flipped them, and then I copied that table in and pasted it. So if you look at our table here in the graph, that's what it looks like here on the Terminator X. If we go over here and look at it, it is a comparable table. The table is the same. So we have a baseline VVE table already planned in here. So the learn table on here is, as the vehicle learns, this will have our percentage of error, and then you can literally just click the button. You can transfer it directly into your base to make your airflow changes. Now, our target AF ratio, right now I've got this kind of loosely set up here, where in our idle range we're looking for about a 14.5. As you get wider throttle, it goes up to 14, and then above 2800, which we would consider power enrichment range, I've got 12.5 across the board. Real simple right now, nothing too fancy. Accelerator enrichment, this is also power enrichment, but it's in our target ratio right here at wide open throttle. So whether or not we need to use accelerator enrichment, probably don't need to right now. I'm not going to worry about this table until later. Same ordeal with temperature enrichment. We can have control over things that we haven't necessarily in the past in a much more simple way. Startup enrichment, though, we will have to probably add some cranking fuel. I have not dove into that, but if you were to go into the HP tuners and looked at your fuel under cranking fuel, you can look at what is our cranking stage. This is not a direct correlation. This is like a multiplier usually. So let's see what exactly it says. Cranking continues. See, that's the hard thing about this side of it, is cranking fuel doesn't necessarily go 1 and 1. Now we have a cranking VE, and that's set to 100% in this situation. So it's looking at the factory VE table and just giving it 100%. And then this does something on top of it as like a multiplier basically. So we will figure that out. We will have to enrich in the cranking side of it, but this is one that we'll probably have to do manually. Now, I haven't found out a way to change the scaling on this, and I'm not sure why it goes all the way up to 999 degrees. That seems crazy. There's got to be a way somewhere, because it seems weird that you would only need these four parts of the table down here. Why would you have all those? If anybody knows, help me out. So we've got after start holdout, which just keeps it rich. Then same ordeal with after start enrichment. So there's a lot of options in here. Now we go into fuel control. This is just DFCO. We'll eventually turn DFCO on, and it'll work just like it does from the factory, where you have RPMs that you can do for reactivation and then decel wait time. So whenever you let off the throttle, you can have it wait for half a second, and then it'll go into DFCO. Pretty self-explanatory. Now, if we dive into the sensor side of it, just all straightforward. Map sensor. Oddly enough, I don't know that there's necessarily a GM 2-bar set up on here, but we could do a custom 2-bar, then bring it in and do a read on it. And if you change this, it will ask if you want to adjust the VVE tables, or the volumetric efficiency table, not VVE because it's not virtual, but it'll ask if you want to adjust based on your new sensor range. I'm choosing no, because I have mine set up right now as a 1-bar sensor range. Coolant temp sense, we got set to just the standard GM default coolant temp sense. Manifold air temperature, same ordeal. Oil pressure, same ordeal. And then fuel pressure, we don't have a fuel pressure specifically on this one. We can do a custom pressure. There probably is a fuel pressure. I'll have to do some digging on it and see if we can bring that signal in as one of those inputs. Okay, so get over to idle. Pretty straightforward. Set point idle speed right now, 700 across the board, regardless of temperature. Might bump it up for the lower ranges. Nothing too crazy. IAC, this is where we're choosing that we're drive-by-wire. If you had some of the different situations, cams, drive-by, throttle, cable, I should say, it gives you a bunch of options. But this one is specifically the drive-by-wire stuff. And we have the option of doing some ramp down setups and some startup positions. This is all tweaking. We're not necessarily worried about this yet. This is something that we'll figure out after we attempt to get the vehicle started. Same ordeal with the IAC part. And then we have a pulse width modulation for IAC. I'm not sure why that output would be needed somewhere else, but it's there. Let's get into the ignition side of it. The base timing table. Super basic timing table that I've pasted in here between 6 and 22 gives us a start point to get the vehicle running. We will then do standard spark tuning like we would on HP tuners in there. There's just the graph represented. Cranking parameters, I've got 10 degrees on crank, and then it's considered cranking until we break 400 RPMs because I know this platform cranks at around 150. Once we break 400, it goes off the crank timing and goes into the base timing. Rev limiters, we've got a 7K rev limiter on spark cut, and then rev limiter 1 is our two-step. There is an input that we can configure that will hold our rev limiter at 2,500 RPMs if we wanted to set up a two-step. Really cool. So the money that you would spend to buy a two-step, you could put it towards this device and have the flexibility plus the two-step. Launch retard gives us the ability to actually retard timing off the launch if we are having traction issues. This is a form of launch traction control, something to play with down the road. This is your NOC table. Basically, I've got it set up to allow up to 5 degrees of timing retard in case we get into NOC. And this is basically 1 retard per ring, 1 retard per revolution, and then timing restore rate is 1 degree per second. That'll allow it to come out of the NOC table. And then we, of course, standard timing versus coolant temp. As we get hotter, we lower the timing, and as we get the air temp higher, we lower the timing. Might be a little bit aggressive. It's just a starting off point. So now that we've got through that, let's look at the I/O. The I/O just simply shows us what we can set up as additional I/O. We could do, I don't know, trigger input that could be enabled as a ground, and then we can configure it or where it's used. This ties back to the I/O underneath the different tables. So if I were to come up here in inputs, and there I have a ground in there that I can define through the pin map. There will be more information as we get this stuff kind of dialed in later on. Then on top of it, we've got the rest of the parameters here. We've got boost. If you have a boost setup where you can do boost control, we're not going to be using this unless we end up doing a centrifugal supercharger. We might set up boost control on that because I still want to do something like that using something like a wastegate. We have nitrous where we have different stages. We activate a stage. We can come in here, do delays. We can do TPS activation, deactivation. We can do timing retard automatically. This is perfect for nitrous. This makes me want to run nitrous because it is so intuitive. We're skipping transmission because we're not using that. And of course, we have the drive-by-wire. Throttle body setup shows you all the part numbers that are available. And then we have pedal versus throttle, which is linear. We'll probably come in here and make it a little bit less linear, put a little bit of a curve in it so we're not getting too much throttle response down low, and then it can kind of ramp up towards the end. Then same more deal, inputs, outputs. None of this stuff is necessarily something that we are going to change because we're going to be using the factory harness. It should work on both the throttle pedal and the throttle body. I've got an adapter to go from the TPS 3-pin and then the 4-pin or whatever it is for the position sensors over to the 6-pin style that's on the later, like the LS2, LS3 style. And then finally, we have the advanced stuff. And the advanced stuff is where you can set up your own custom tables. In particular, this is where you would come in here, set up a table for something like E85, where you know if you bring in an E85 sensor, you take the input, define it as a range, basically 0 to 100%, and then you add how much fueling needs to be added based on that. So you can come in here and say at 0% add 0 fueling, at 85% add 30% fueling, or wherever it needs to be to achieve your target airflow ratios. You can do this. You have multiple custom tables. As I said, you've got 4 1Ds and 4 2Ds, and then per gear table stuff kind of ties back. There's some transmission stuff that you can necessarily set up even though you're not controlling transmissions, where it will look at things and make adjustments off of RPM speed, etc., etc. We're not getting into that. This is the basis of kind of what I went through to dial in this stuff, get everything set up, get a base map, something that we should be able to start running on. Okay, was that enough drinking from a fire hose for you? Don't worry, we're going to dive more in depth into particular sections of this software, this tuning, whenever we get to that point. But I wanted to kind of give you an overview of how I had gone through and started setting up my table by using HP tuners. I mean, most of that information was already readily available. And so those of you who might be a little bit worried about going over to a aftermarket ECM, man, it's not going to be that bad. Like, a lot of the information's there. It gives you a lot more flexibility, a lot more ease of tuning, and it gets rid of so much crap that you don't need to mess with. That's what I'm looking forward to, is having the simplicity to make changes and then have this thing self-tunes, does tuning on the fly, all that jazz. You can just, I mean, that's where the good life's at. So I'm super excited to make additional videos in the future. Not to say that we're going to get away from the E67 just yet. I really want to get this thing running on the E67, but it's going to be hard not to just throw this kit in and get this car rocking and rolling. So, hey, I want to thank everybody as always for stopping by, for subscribing, for supporting the channel. You guys are the greatest. Thanks for stopping by the garage, and remember, ABT, always be tuning.